So, what's really going on inside the mind of a self-driving car? How does it look at a chaotic world filled with traffic and pedestrians and all kinds of unexpected stuff, and decide what to do next? Well, today we're going to pull back the curtain on the two competing philosophies, the two big ideas that are battling it out to become the brains behind our autonomous future.
Okay, let's get right into it. At its very core, every single decision an autonomous vehicle makes, every tiny turn of the wheel, every tap of the brake, it all comes down to this one fundamental question. And the way you answer it, well, it splits the entire field into two completely different ways of thinking about how a machine should drive.
But first, before we dive into those two philosophies, we gotta lay the groundwork. Just about every self-driving car out there follows this basic blueprint. It's called the Sense, Plan, Act paradigm. First, the car senses the world around it with all its cameras and LiDAR. Then, using all that data, it plans its next move. And finally, it acts on that plan by telling the steering wheel and the pedals what to do. It's this super logical three-step dance. But it's in that middle part, the how of the plan, that's where things get really interesting, and where our two philosophies go their separate ways.
First up, we've got the meticulous engineer. This is the classic, the traditional, the modular approach. You can think of it like a perfectly designed factory assembly line, or a team of expert specialists, where every single person has one very specific job and they all work together in a carefully designed pipeline.
This system, this hierarchy, was actually pioneered way back in the early days of autonomous driving in those big DARPA challenges. It breaks that plan stage into three clear levels. At the very top, you've got the mission planner. That's basically your Google Maps, figuring out the overall route from A to B. Then the behavioral planner steps in to make the tactical calls. Like, should I change lanes now? Or how do I handle this intersection? And finally, at the bottom, the motion planner calculates the precise moment-to-moment path for the car to follow without hitting anything. It's a neat little waterfall, with each level feeding the next.
Okay, so you've got a path. Now what? How does the car actually steer itself along that path? Well, one really popular technique in this modular world is geometric control. And it's actually pretty elegant in its simplicity. The controller it looks ahead at a single point on that planned path, some set distance away, and it just does the math to figure out the exact steering angle it needs to get there. That's it. It's robust, it's relatively simple to build, and it works. But what if you want something a bit more sophisticated? Well, that's where Model Predictive Control, or MPC, comes into play. Instead of just looking at one point, MPC is like a chess master. It uses a detailed model of the car's actual physics to simulate and optimize a whole sequence of moves over the next few seconds. It's constantly running these tiny simulations, asking, if I do this, what happens next? What is the absolute best series of moves I can make right now? The catch? It takes a ton of computing power, which is a huge problem when you need to make decisions in a fraction of a second.
Okay, so that's one whole way of thinking. Now let's flip the script completely and look at our second philosophy, the intuitive learner. This is the newer, you might even say more radical approach, and it's all powered by deep learning. Instead of building a whole bunch of separate specialized modules, the goal here is to create a single unified brain that learns to drive from experience, kind of like we do.
And this slide just lays it all out perfectly. On the one side, you've got that modular pipeline we just talked about. All these different boxes that have to talk to each other. You can see the problem, right? If your perception module makes one tiny mistake, that error can just tumble right down the line and cause a total failure. But on the other side, you've got the end-to-end approach. Sensor data goes in one end, and steering, throttle, and braking commands come right out the other. It's one single elegant system, a direct line from seeing to doing.
And here's the really cool idea at the heart of this. This whole approach is trying to copy the intuition of an experienced human driver. Think about it. When you have to swerve to miss a pothole, you're not sitting there running through a 3-level planning checklist. It's a reflex, right? It's pure gut instinct. And that's exactly what end-to-end learning is trying to build, a kind of digital reflex.
So how do you teach a machine that kind of intuition? Well, one way is through something called imitation learning. Essentially, you have the AI watch millions, literally millions of hours of footage of expert humans driving. The model sees what the human driver sees through the sensors, and it sees what the human driver does with the wheel and pedals. Over time, it just learns to connect the dots. It's basically learning by playing the world's most high-stakes game of copycat.
But what if you want the AI to learn something brand new? Something maybe even a human expert can't do? Well, that's where deep reinforcement learning comes in. And this is wild. You put an AI agent into this incredibly realistic simulation. Think of it like the ultimate driving video game. And you just let it go. It learns by pure trial and error. It gets rewarded, gets points, for good things, like staying in its lane, and it gets penalized for bad things, like causing a crash. After driving for millions and millions of virtual miles, it can literally teach itself how to do incredibly complex things, all without ever seeing a human do it first.
So that brings us to the big showdown, the great debate. We've got the meticulous engineer versus the intuitive learner, the handcrafted system of logical rules versus the self-taught neural network. So which one is better? Well, like with most things this complex, the answer? It's not that simple.
And this chart really gets to the heart of the trade-offs. Let's start with interpretability. The modular method? Totally clear. If it screws up, you can pop the hood and point to the exact part that broke. But the deep learning driver? It's a black box. When it makes a mistake, sometimes even its own creators have a hard time figuring out why. Then you have complexity. Building that modular system is a beast. It's complicated and expensive. The deep learning architecture is actually much simpler. But maybe the biggest one is generalization. The modular system struggles with things it wasn't explicitly programmed for. The deep learning model, on the other hand, has the potential to handle brand new situations because it's learning the underlying patterns of driving, not just memorizing rules. So you see the tension, right? It's the safety and clarity of the engineer versus the raw power and adaptability of the learner.
So where does that leave us? Who's going to be in the driver's seat for our autonomous future? Which of these philosophies is going to win out? This is the question shaping the entire industry right now.
And you know what? The most likely answer isn't that one side wins, but that they team up. The industry is realizing the future is probably a hybrid. Imagine this: a car that uses that super reliable, easy-to-understand modular system for 99% of its driving, but when it runs into something really tricky, something a human would need intuition for, it can hand off control to that powerful end-to-end model. It's about getting the best of both worlds, rock-solid safety and predictability, with a dose of human-like intuition when you need it most.
And that leaves us with one final thought, and it's a big one. This whole debate, it really boils down to an issue of trust. As we get ready to hand over the keys, we have to ask ourselves, what do we demand from these machines? For a self-driving car, what's more important, making the right decision, even if we don't understand how, or being able to explain precisely why it made the decision it did, even if that limits its ability? Think about that. Because the answer to that question, well, that's what will truly define the road ahead.